So this is the 2025 Higher Level Applied Maths Solutions, question 3a. Block A of mass 8 kilograms and block B of mass 4 kilograms lie at rest on two rough horizontal tables. The coefficient of friction between A and the table it lies on is mu A, and the coefficient of friction of B and the table it lies on is mu B. Mu of B is equal to twice mu A. The blocks are connected by a light inextensible string which passes under a smooth movable pulley of mass 12 kilograms. After the system is released from rest, the blocks and the pulley move and the string has a tension of 32 newtons. Calculate mu of B. Okay, so I've just drawn the three particles here. If you like, I have block A, block B and the pulley in the middle, and I put in the forces acting on each one. So if you take block A, for example, this is block 8 here. Block A here, I should say, it has a mass of 8 kilograms, so it has a weight then of 8g. Tension in the string to the right, friction to the left, which is mu A times OR. So OR is the reaction up along here. So the pulley, oh, by the way, I have the reaction here is equal to 8g. Because the block doesn't move in a vertical direction, the reaction is just 8g. So we have the pulley in the middle. It has two strings up along here, both with tension T. It has a weight of 12g. It has a mass of 12 kilograms. And on the right here, we have block B. So block B has tension to the left here. It has a reaction force, I'm calling it S. And acting down, we have a mass of 4 kilograms, so a weight of 4g, and then friction to the right of mu bs. Now, the reaction then here is going to be S is equal to 4g. Forces up are going to be equal to the forces down because the block doesn't move in a vertical direction, so the reaction is just 4g. Okay, so I've drawn in the accelerations as well. So I'm calling the acceleration of block A, the acceleration of block B to the left. So the pulley then is going to have acceleration down of A plus B over 2. Okay, so let's start writing some equations. I have two equations here anyway. I have R is equal to 8g and S is equal to 4g. So let's start with block A. We can say here that the tension to the right, the block is going to move to the right, so we can say 32, which is the tension, minus the force to the left, which is mu A times OR, and we know that OR is just 8g, and that's going to be equal to its mass times acceleration. Well, its mass is 8, and we're saying the acceleration is A. So that's my first equation. On the right-hand side here, we have block B. So it's moving to the left, so we can say the tension 32 minus the friction to the right, which is mu of B times S, and we know that S is just 4g. It's equal to its mass, which is 4, times its acceleration, which is B. So let's do the pulley in the middle then. So we have, let's see, it's moving down. So 12g minus the two tensions, which is twice 32, is going to be equal to its mass, which is 12, times its acceleration, which is A plus B over 2. Okay, so we have our three equations here. Let's just see what we can do with these. Let's look at the one in the middle first anyway. So we'll just simplify it. 12g minus 232, 64 is equal to, well, I can divide the 2 into the 12. That'll give me 6 times A plus B, and I can just divide by 2, so that's 6g minus 32 is equal to 3 times A plus B. Okay, now we're told that mu of B is twice mu of A, and we have to find mu of B, so I want an equation with mu B in it. So what I'm going to do is take this equation here, 32, I'm going to take out mu of A, and I'm going to put in half of mu of B, because mu of B is equal to twice mu of A. So in here I'm going to put in mu of B over 2 times 8g is equal to 8a. So that'll give me, if I just multiply, well, actually what I can do here is just divide that 2 in. So I've got 32 minus 4g mu b is equal to 8a. So what I'm going to do now is just divide everything by 4. So that'll leave me with 8 minus g mu b is equal to 2a or just A is equal to 8 minus G mu B all over 2. So over here on the right hand side for block B, I can just get B on its own here. I can actually divide by 4 first, so let's do that. So I'll get 8 minus G mu B is equal to B. So now what I'm going to do is just substitute these two, this and this, in here. So let's do that. So we've got 6G minus 32 is equal to 3 times, well, A is 8 minus G mu B over 2, and we want to add B, which is just 8 minus G mu B, let's say over 1. So you can see now we have an equation here with just mu of B in it, so all we got to do is isolate mu B, and that's what we were asked to do. So let's see, let's take 6G minus 32 is equal to 3 times, let's add these two equations anyway. So we got 2 here, so that's 8 minus G mu B, plus we've got to double this, so it's plus 16 minus 2G mu B. Okay, so let's just simplify this a little bit. So we've got 6G minus 32 is equal to 3 times, we have 8 plus 16, which is 24. We've got minus G mu B, and we've got minus 2G mu B, so that's minus 3G mu B, and that's all over 2. So let's just, what will we do here? We'll multiply everything by 2, so that's 12G minus 64 is equal to 3 times 24, so that's just 72, minus 3 3's 9G mu B. So let's just get mu B on its own. So what I'm going to do is take 12G minus 64 minus 72, that's minus 136. Then I'm going to divide by that minus 9G. That'll leave me with the mu of B here on the right. Okay, so that's really it. You've got mu of B then is equal to, you've got 0.208616 and so on and so on. So probably, I don't know, 3 or 4 decimal places should be okay here. So it's going to be approximately 0.209, let's say. That's it for the first part. Okay, let's look at the next question then. Calculate the acceleration of the movable pulley. Well, we know the acceleration of the movable pulley is A plus B over 2. So we know that A is equal to 8 minus mu of B times G over 2, and we know that B is just 8 minus mu of B times G. So A plus B over 2 then is just 8 minus, so it's mu of B, so it depends on how many decimal places you used in the previous question, but let's say it's 0.2086167 G. I've used too many decimal places there probably, but let's do that over 2, and then it's plus 8 minus 0.2086167 times G, and all of that is over 2. Okay, so when you do all of that, you will get 4.4666667 and so on, or let's say to 2 decimal places 4.47, this acceleration, so it's meters per second squared. Okay, so this is question B. An electrician needs to link 7 landline telephones in an office. The telephones A to G need to be connected by cables within the same electrical network. The table below shows the distance in meters between the different telephones. Okay, so we have to start with telephone A, use Prim's algorithm to calculate the minimum length of cable required. So part 2 just says draw the network, and then part 3 says name another algorithm that could be used to calculate the minimum length of cable required. So the other algorithm is just Kruskal's algorithm. So I'm going to do parts 1 and 2 together. So let's start with, let's say node A. So I'm going to start here at A, and I'm going to work along here horizontally. So if we look for the minimum weight along the horizontal row, you can see that it is 9 and it is connected to B. So if we start here, let's say at A, and we move up here to B, that weight is 9 meters. Okay, so I'm just going to cross out the corresponding weight as well as we go along. So the corresponding weight here would be AB or BA. So we need to now look at nodes A and B and find the minimum weight from either of those nodes. So let's look at A and B horizontally. Well, we've got 14, 13, 12, 15, 18, 13, 14, 12, 9, and 15. So the second one here is 9, and that's connected to F from B. So let's just connect that up. So this is F here, and this is also 9 meters. Okay, so now we have 3 nodes. We have A, B, and F. Let's just, by the way, cross out that 9, that corresponding 9. So that would be B and F. So we need to look at F and B. So it's here. Okay, so now we're going to look at nodes A, B, and F horizontally. So if you look along here at A, look along here at B, look along here at F, the smallest number would be this number here, 8, and that's connected to G. So let's connect F to G. Let's say it's down here, and that has a weight of 8 meters. So just circle that one and cross off the corresponding one. Okay, so now we have 4 nodes, A, B, F, and G. So we need to look for the smallest weight along those rows. So again, we've got, say, 12 here. We've got 12 here. On B, let's look at F. We have a 9. And on G, we have 12. So 9, again, is the smallest. So we're going to just circle this 9 here. And that's F to D. So let's look at D to F, which is here. So I'm just going to cross that off as well. So now I need to go from F to D. So let's come up along here to D, and that is also 9 meters. Okay, so now we've got 1, 2, 3, 4, 5 nodes. So we've got to look for the smallest weight in those 5 rows. So you can see along A here we've got 12, along B we have 12 as well, along D we've got a 10, and along the row G we have 12, so 10 seems to be the smallest. So the smallest weight here is 10, so that's from D to E. Look at from E to D, I'll just cross that off. So we want to go from D to E. So this is D here, so I'm just going to connect that up here to E. And that has a weight of 10 meters. Okay, so now we've got 1, 2, 3, 4, 5, 6 nodes at this stage. So let's see if we can find the smallest number from all of those 6 nodes. So it must be to C. Let's have a look anyway. We have along here, along the A row, we've got 12. Along the B row, we've also got a 12. We don't have C yet. Along the D row, we've got 11 to C, from D to C. And then we have on the E row, we also have an 11, but that's to F. So if you have a look at this one here, this is from E to F. But if I was to draw a line here, an arc here from E to F, I would produce a cycle, and we can't have any cycles in a minimum spanning tree. So I can't use this 11 here from E to F, or from F to E as well. Okay, so we're here at this stage. We're going from D to C. From E then we have 12 is the lowest. From F, no. And from G we have 12. So 11 here seems to be the lowest. So I'm just going to circle this one here. That's from D to C. So if I was to draw that, it would look like this, from D to C. And that has a magnitude of 11 meters. So we have all the nodes at this stage. That was from D to C. So from C to D, we can cross off. So we have 1, 2, 3, 4, 5, 6, 7 nodes at this stage. And that is it. So this is what the minimum spanning tree would look like. And we were also asked to find the distance, find the minimum distance, the minimum length. So it's just simply 9 plus 9 plus 9 plus 8 plus 11 plus 10. So that's 56 meters. So this would be the answer to part 1 here. This is the answer to part 2. And then naming the algorithm that, and a different algorithm that could be used, that's just Kruskal's algorithm. Okay, so that's it for this question.